Okay, welcome back, and we're carrying on with Module 6, our numeric and geometric patterns, and let's dive straight in and let's see how you went with these. Ask for the next three terms. Well, what's happening here is we are adding, so we're adding 4, so this becomes 19, 23, 27. Here we're doubling, 32, 64, 128. Here are the perfect squares. That's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. This one is reducing by 4. No, it's not. It's reducing by 6. 1 take away 6, negative 5. Negative 5 take away 6, negative 11. Negative 11 take away 6, negative 17. This one's dividing by 10. 1/10, 100th, 1,000th. This one is, we're adding 1, we're adding 2, we're adding 3, we're adding 4, we're adding 5, we must add 6. We must add 7, and we must add 8. Okay, so that's an interesting one. The amount that we are adding is growing by 1 each time. Okay, we said we'd leave that question. Let's look at this one. How many squares in figure 1? Well, there's just 1. How many in figure 2? There are 4. How many in figure 3? There are 9. Right, without drawing it, can we work out what's the relationship? What are we doing to get from the bottom row to the top row? We are squaring. 4 becomes 16. 5, 25. 9, 81. How are we going to go the other way? What's the undoing of squaring? That's right, square rooting. So n, if it's figure number n, the number of squares will be n squared. If there are p squares, how do we go back? We square root p. What does p represent? Any number we like. If p represents 9, then the answer would be 3. 9, 3. Okay. All right. Let's look at this one. This one's got some triangles and how many lines? Okay, we're going to ask you, if you haven't tried it, pause the video, have a go, and then we'll have a look. Right. So, number 1's got 1 triangle. Number 2's got 2 triangles. Number 3's got 3 triangles. That's pretty easy. 4's going to have 4 triangles. 5's going to have 5 triangles. N is going to have n triangles. If they're t triangles, which figure number are we on? We're on figure number t. Right, notice that these numbers are exactly the same each time. Okay, now let's look at the number of lines. Well, the first one has got 3 lines that we would need to draw this triangle, this shape. The next one's got 5. The next one's got the same 5 plus 2 more, 7. Figure number 4 has got all of the ones before plus 2 more, it's got 9. Right, now we're going to look for a rule here. And as I've said to you all along, when this is growing by 2, that suggests multiplying by 2. So if we multiply our figure number by 2, we actually need to then add 1. Have a look. Multiply by 2, add 1. 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 2n plus 1. Multiply by 2, add 1. 2t plus 1. Now, how would we go backwards if we knew the number of lines? How would we get back to the figure number? Right? Remember, the figure number and the number of triangles are the same number. But how would we go backwards? Well, let's just look at the rule. Double and then add 1. Let's undo that. Remember, we go backwards. Remember the getting dressed and the getting undressed. Okay? Double and then add 1. Subtract 1 and then divide by 2. So subtract 1 and then divide by 2. And remember, these numbers are the same. Okay? So this one will also be p minus 1 divided by 2. Okay. All right. Here's one. All right, and we might have done one really like this. We might even have done this one. Okay, but try it again because I think we're hopefully getting better at this now. Okay. Okay, so it looks like the number of figures and the number of squares are exactly the same each time. Right, but how many matches do we use? Right, so for 2 we use 7. Then it grows by 3. And because it's growing by 3, we're going to take this number and multiply by 3 and then see if there's any adjustment that we need to make. If we multiply this by 3, we get 6. Add 1, we get 7. Multiply by 3, add 1. Multiply by 3, add 1. Multiply by 3, add 1. Now let's think about going backwards. Multiply by 3, then add 1. Subtract 1, and then divide by 3. This is figure number 100. Right. Figure number 100 would need 301 matches. Okay. Let's look at this one. How many matches would we need for figure number 5? Well, let's write down. Here we're needing 4. Here we're needing 4 plus 3. We've got a total of 7 matches. And then another 3, 10. So it looks like we are adding 3 each time. Because we're adding 3, we're going to multiply our figure number by 3 and then see what the adjustment is. Times 3, add 1. Times 3, add 1. Times 3, add 1. So 5, figure number 5, times 3, add 1. Okay, and our answer would be 16. Okay, what about figure number n? Well, we'd take n, then we'd multiply by 3, and then we'd add 1. Now, we don't normally write this like this. We normally write 3n. That just means 3 times n. And we write the number before the variable. So 3n plus 1. Okay, all right, this one. Can we link the figure number to the number of small squares? Okay, so here we've got 2. Here we've got 5. Here we've got 10. Here we've got 17. Okay, now, if we look at this, there's always 1 on its own up at the top here. There's this 1 over here. 1. 1, 1. This number over here, in figure 2, we've got 2 squared. We've got 4. In figure 3, we've got 3 times 3. We've got 9. In figure 4, we've got 4 squared plus 1. So this one is 1 squared plus 1. For figure 1. This one is 2 squared plus 1. This one is 3 squared plus 1. And this one is 4 squared plus 1. And this number that we're squaring is actually the figure number. So figure 3, we square 3 and add 1. For figure 4, we square 4 and add 1. So, how many squares will there be in figure n? Okay, well, figure n will have n squared plus 1 small squares. Okay, all right. Now, that's the end of this module, module number 6. Okay, and it's really been around looking for patterns. Notice we've left some blank pages here for you to make up some more examples for yourselves and for your friends, or for your teacher to make up some for you as well. Okay, all right, we hope you enjoyed this module, and we look forward to seeing you for the next one.